we're looking at light scattered off of small droplets of mineral oil that are injected into the moving air. The near-field velocity measurement system that we've been working on is able to measure local air velocity around wind tunnel test articles that we'll put into our large-scale wind tunnels here at AEDC. And it does this by looking at light that's scattered off of small droplets of mineral oil that are injected into the moving air. That light goes into a detection system that analyzes that light and determines what the air velocity is by assuming that the air velocity is the same as that particle velocity. The return on investment that we see is going to be that we'll provide extra information to customers that are using our wind tunnels. Those customers will then better understand what the flow field is around these test articles that are models of the weapons systems that they will be providing to the Air Force in the future. By knowing that detailed information early on in the acquisition cycle, we can avoid problems that might develop later in the acquisition cycle, and we know historically that those are very expensive problems to fix when those problems are identified late in the acquisition cycle.
We want to measure near the flow field above the airplane model surface. AUR developed this small sub-miniature probe head in order to install this probe head inside of the test article model to measure the flow field very near the model. We want to know and understand what is going on and what is happening very near the flow field, very near the surface of the model. This is one of the smallest LDB, laser Doppler velocimeter probe head to measure 3 velocity components. By using this equipment, they can measure all the flow field about the air fighter, and then the Air Force engineer can solve the problem, like the stability of the air fighter and viability air fighter, and even the fuel efficiency of the air fighter. So that's a lot of contribution we can get by using this equipment.
We envision using this laser velocimetry probe with its miniaturized laser delivery head in our large-scale wind tunnels. Our 16T wind tunnel is a 16-foot by 16-foot wind tunnel, one of the largest in the world, to get the detailed flow rate information around the test articles that are going into those wind tunnels.
Air Force SBIR program is very, very important to the small business company like AUR. AUR could not develop this kind of technology and this kind of product. So all this equipment is developed under the Air Force SBIR program.
This is a success story from an SBIR standpoint in every sense of the word, because we received a Phase 2 delivered product. There were some identified improvements that could be made to it. The CRP follow-on project occurred, and we have received several probes, much improved from the original Phase 2 delivery, but it's been several probes that we have received, and they've all worked splendidly. They've all done exactly what the company has promised. So again, a success story in every sense. And we've got uses for these new probes, these new highly developed, highly improved probes that AUR has delivered to AEDC.